In this video, we look at how we can use vectors to calculate angles between three-dimensional objects. We already have some results about angles. First of all, we know how to use the scalar product to find the angle between two vectors, and that reduces down to the formula cos theta is a dot b divided by the length of the vector A times by the length of the vector B. If we want to ensure that we find the acute angle between the two vectors, then the formula needs to just be modified slightly, and to make sure we get an acute angle, we've got the cos of the angle is the modulus of the scalar product a dot b divided by the length of A times by the length of B. And we've also already seen that the angle between two lines is the same thing as the angle between the direction vectors of the two lines. Now, our first new result is the process for finding the angle between a line and a plane. Now, the angle between a line and a plane is the angle between the line and the projection of the line onto the plane. What we can do quite easily is to find the angle between the normal to the plane and the direction vector of the line. And we know that we can find the acute angle between the normal and the direction vector by using the formula cos theta equals the modulus of the scalar product of n and b divided by the length of the vector n times by the length of the vector b. Now, this angle theta is not the angle that we want, but the angle that we want is just 90 minus theta. So the process for finding the angle between a line and a plane is that we need to find the acute angle between the direction vector of the line and the normal of the plane, and then the required angle is 90 minus theta. So let's have a look at an example which puts this into practice. We wish to find the acute angle between the line, whose equation is r equals 152 plus s times 3 minus 1, 4, and the plane with the equation 3x minus 2y minus 4z equals 8. Now, we know the first thing we've got to do is evaluate the acute angle between the direction vector of the line, which is the vector 3 minus 1, 4, and the normal to the plane, which is the vector 3 minus 2 minus 4. So if theta is the acute angle between the direction vector of the line and the normal, then we know that cos theta is the modulus of the scalar product of the direction vector with the normal divided by the length of the direction vector times by the length of the normal. So first of all, we've got the scalar product to work out. The scalar product is going to be 3 times 3 plus minus 1 times minus 2 plus 4 times minus 4. So that is 9 plus 2, take away 16. So we've got there minus 5 as the numerator of our fraction. The magnitude of or length of the vector 3 minus 1, 4 is the square root of 3 squared plus minus 1 squared plus 4 squared. So that's the square root of 9 plus 1 plus 16. So that is the square root of 26. The magnitude or length of the normal vector is the square root of 3 squared plus minus 2 squared plus minus 4 squared. So that's the square root of 9 plus 4 plus 16, which is the square root of 29. So we've got cos theta is the modulus of 9 plus 2 minus 16, which is the modulus of minus 5, which is 5, over root 26 times by root 29. That tells me that theta is 79.5 degrees, which means that the angle between the line and the plane, which is 90 minus theta, must be 10.5 degrees. Now we want to have a look at the problem of finding the angle between two planes. The acute angle between two planes is found by determining, first of all, where the common line of the two planes is. We then mark in a line on the first plane which is perpendicular to the common line, and a line in the second plane that is perpendicular to the common line. The angle between the two planes is then defined to be the angle between those two lines, L1 and L2. Now we're going to draw in some normals. First of all, we're going to draw in the normal to the plane, the first plane, and we're going to draw in the normal to the second plane. Now we know that the normal to the first plane is certainly going to be perpendicular to the first line because the first line lies in the first plane. And similarly, we know that the normal to the second plane is certainly going to be perpendicular to the second line because the second line lies on the second plane. So if we look at the quadrilateral formed by the two lines and the two normals, the moment we've got an angle of theta in the quadrilateral, we've got two right angles. So at the moment we've got 180 plus theta. So the remaining angle must be 180 minus theta. Now that means that the angle between the two normals is 180 minus theta, or equivalently, the acute angle between the two normals is just theta. In other words, the acute angle between two planes is exactly the same as the acute angle between the two normals. So we can find the acute angle between two planes by simply saying that cos theta is the scalar product, the modulus of the scalar product of n1 and n2 divided by the size of n1 times by the size of n2. So to put this into practice, if we wish to find the acute angle between the planes 7x plus 2y minus 3z equals 21 and 3x minus 2y minus 4z equals 8, we simply observe that the acute angle between the planes is exactly the same as the acute angle between the normals, and therefore what we need to find is theta, where theta is the acute angle between the normal of the first plane, which is 7, 2 minus 3, and the normal of the second plane, which is 3 minus 2 minus 4. So we've got cos theta is equal to the modulus of the scalar product of 7, 2 minus 3 with 3 minus 2 minus 4 divided by the magnitude of 7, 2, minus 3 times by the magnitude of 3 minus 2 minus 4. The scalar product gives me, the modulus of the scalar product gives me the modulus of 21 plus minus 4 plus 12. The magnitude of 7, 2, minus 3 is the square root of 7 squared plus 2 squared plus minus 3 squared. So that's the square root of 49 plus 4 plus 9, which is root 62. The magnitude of 3 minus 2 minus 4 is the same thing as the square root of 3 squared plus minus 2 squared plus minus 4 squared. That's the square root of 9 plus 4 plus 16, which is root 29. The numerator is the modulus of 29, which is itself just 29. So we've got 29 over root 62, root 29. So that tells me that theta must be 46.8 degrees, and theta is the acute angle between the normals, which is precisely the same thing as the acute angle between the two planes. To finish this video off, just pause it at this stage and have a go at these questions. And that completes our work looking at how we can use vectors to determine angles in three-dimensional space.